Welcome back, you guys. It's time for lesson 8-7. It might be helpful for 8-7 to review your notes from 8-5 because if you guys remember, 8-5 was about direct variation. And direct variation equations looked like this. Y equals k times x. Now what we knew about direct variation equations, what you should remember, hopefully, is that direct variation equations always start on our graph. They're linear functions, but they always start at the origin point. Remember, and then once you found your k, you would know what the slope was. K was our slope. And that's how you would graph those equations, right? What we're doing with slope-intercept form is we're figuring out what happens if the line doesn't start at our origin point. What happens if the line crosses our y somewhere else? What if our line looks more like this? We're going to find out today. Slope-intercept form. Oops. Slope-intercept form looks like this. Y equals mx plus b. Now this is an equation that's going to follow you through Algebra 1, Algebra 2, geometry. This is going to keep coming up because anytime you need to find the equation of a line quickly, we're going to use slope-intercept form. What you need to know about slope-intercept form is that the m is our slope, just like our k in direct variation equations. M is our slope, and b is our y-intercept. Now you guys should remember the word y-intercept from earlier in the chapter, but if you don't, the y-intercept is the place where x equals 0, or the place where our line touches the y-axis. So for this line, our y-intercept would be right here. This is why direct variation equations work, because their y-intercept is 0. So it's basically y equals mx plus 0, right? And if you have plus 0, you're not adding anything, so we just say y equals kx. But not all lines intersect the graph at 0, so we need to know this other equation. So part of what you'll need to know for your homework is, A, if I just told you, write an equation in slope-intercept form for a line that has a slope of 3 and a y-intercept of -1. What you're going to do is you're going to take these numbers and put them into this equation in the right places. So I'm going to say y equals slope times x, so 3 times x, plus our y-intercept, which is -1. You can leave it like this, or you can rewrite it like y equals 3x minus 1. Because plus and negative is like minusing, subtracting. So far, so good. I think you guys can do that. I believe in you. Yeah, you just plug them in, no matter what it is. If I said your slope was 1/2 and your y-intercept was 8, do the same thing. Y equals our slope times x, 1/2 times x, plus our y-intercept, which is 8. Yeah, so you guys got that. I think you can do it. I'm so confident. The other thing that will happen is instead of being given your y-intercept, we're going to, they'll give you the equation, and we're going to try to graph it. So let's try graphing that one we just had, with y equals 3x, was it? I don't know, it doesn't matter. I got it wrong. Everyone will know. we're just gonna graph this random line that I just made up just now. First things first, draw your graph. We're gonna draw our graph. Now, like I said, our y-intercept is the place where x equals 0, or the place where our line crosses our y-intercept. So if I'm looking at 3x minus 4 right now, our y-intercept is going to be this number right here, right? And that's minus 4. So what I know about that is our line is going to intersect the graph at negative 4. So I'm going to come down 1, 2, 3, 4 and put myself a point. Now this is our slope, right? So m is our slope. A slope of 3 is the same as saying 3 over 1. So we're going to rise 3 and run 1. So from our 4, we're going to rise 3 and run 1. We went up 3, 1, 2, 3, over 1. And then all you have to do is connect your dots, and you have a line. So far, so good. We'll try one more. I'll show you guys what happens if you have a negative slope. If our y equals negative 2x plus 4, we always start with our y-intercept every time. Our y-intercept is the place where our line crosses the y-axis. So if it's positive 4 right here, I'm going to count up to 4, 1, 2, 3, 4, and put a dot. Put our point in. Now this time our slope is negative 2. So I'm going to take negative 2 over 1, right? And so I'm going to rise negative 2. Now if I'm rising a negative number, I'm not going to count up 2, I'm going to count down 2. So I'm going to go down 2 and over 1. So our line looks like this. Well, I kind of missed. That's okay. So notice when you have a negative slope, your line is going to be going down. When we had a positive slope, our line went up. That's one way to check and see if you're doing it right. And that's it.